Alright, let's do another LeetCode problem. Squares of a sorted array. Oh, I should have reset my main back to everything being clear. Drawing mode. Grab blue. Get a nice... Well, we'll have to resize this palette anyway. Let's see what we have here. Sorted squares. LeetCode number 977. Squares of a sorted array. Given an integer array nums, sorted in a non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. Oh, uh-oh. Oh, okay. So I was worried about overflowing. Looks like our constraints are our numbers are between 10 to the 4th, which, if you square that is 10 to the 8th. So we don't have to worry about overflowing integers. That would have been pretty terrible. We do have to worry about negative integers. So we do have to reorder the array. Let's think about this. A naive approach would be to assign a new array. We'll clear this drawing. Would be to assign a new array and to iterate over the numbers array and square them, and at the end just sort it using a built-in sort algorithm. That would take O to the n extra space, with n being the size of the int array nums, and it would occur in n plus n log n time. N to square all of the values, and n log n to sort it. So actually I could do it in place and then sort it afterwards, which would be an n log n solution. How else could we sort in place? Could we use an array deck? We could use an array deck and add to the beginning or to the end of the array based off the square. So that'd be a priority queue. We could use the built-in priority queue to do a lot of that logic ourselves. And then it would be already sorted. Which would take O to the n memory, but would occur in O to the n time as well. So we'd go from O to the n log n time, basically, n plus n log n to O to the n, but it'd be like O to the 3n or something. But basically O to the n time. And O to the n memory. So I haven't done a solution with PriorityQueue before. So let's try doing that. Let's try doing a PriorityQueue. Okay, so our function is going to be declared as function sorted squares, taking the input nums of type int array, and it will return an int array. And we'll start by assigning our value PriorityQueue, which is a queue of type int. Well, heck, as long as we're getting all idiomatic. I want to see if I can do a comparator. Val comparator is compare by the type variable is int, and our lambda function is going to just square the receiver. And it will be done in an increasing order, because this returns its squared will be positive. PriorityQueue taking the argument comparator. For num in nums, pq add what are all these? What are all these? We're gonna do add pq add num. And at the end, we're just going to do val output equals int array of size nums size. Okay, and well, pq is empty. Variable I equals 0. Output I equals pq poll and increment I, and then return output. Cool, we have a very idiomatic Kotlin solution which will run in O to the n time and take O to the n space. That actually looks pretty good. It's very readable. Assuming I used all the built-in library functions correctly, this should compile and work well. And assuming the IDE has all the required library functions, which it might not. Let's make sure we didn't type num anywhere where I should have done nums. Just trying to make sure I didn't do anything stupid like misspell comparator. Okay, interestingly it doesn't highlight. Unless I search for it. Okay, cool. Comparator equals compare by int it times it. Value PQ equals PriorityQueue int with the passed parameter comparator. For num and nums, PQ add num. Output equals int array initialized with the size of numbers, which is our input. Our variable I, which is our pointer to our new array of output, is 0, while PQ is not empty. Output I equals PQ poll. Increment I. Cool. We have a very idiomatic solution, a very Kotlin idiomatic solution. Let us run it and see if we have any errors anywhere. Wrong answer. Oh, shoot. That was stupid. It was almost right. This is right. We can submit this. Wrong answer. What? Why is this wrong? It's not sorted. Oh, I'm raising to the power of fourth. Oh, bollocks. I got ahead of myself. Bollocks. Alright, well this is correct. That's too bad. I really felt smart doing that. Ah, I was so close. Alright, let's take a look at some solutions. Sort two pointer. Hmm. Okay. That's fine. Well, we got our fourth LeetCode problem done today, which is great. Can call that good. Here's a one-line solution. That's slick. Alright, cool. Nice. We did alright there. We'll call that good though.